Answering particulate nature of matter questions with detailed explanation. Let's go. Question number 1 says, neutral atoms of neon with atomic number 10 have the same electrons as A. Oxygen 2 minus, B. Calcium 2 plus, C. Potassium plus, and D. Magnesium 2 plus. First of all, let's look at what the atomic number of let's look at what a neutral neon looks like. Now, for neon, bring this. I've already written down all our options. For neon, it has an atomic number 10, and this is what a neutral neon looks like. You see, it does not have charges like this. Now, when you see a negative above an element or an atom, it means that element has gained 2 electrons. So for oxygen here, it means it has gained 2 electrons. For calcium here, it means it has lost 2 electrons. For potassium here, it means it has what? Lost 1 electron. And for magnesium, it means it has what? Lost 2 electrons. So oxygen has an atomic number of 8. Calcium has an atomic number of 20. Potassium has an atomic number of 19. And magnesium has an atomic number of 12. You see how I'm purposeful about writing the way this atom. So the atomic number is written below here. Now, if this has lost 2, it means what? 8 minus 2. For this, it means what? 8. If this has gained 2 electrons, it means 8 plus. So 8 plus 2, this has lost 2 electrons, so 20 minus 2. This has lost 1 electron because it's a positive here, means it has lost 1 electron. 19 minus 1, and this has lost 2 electrons also, so it will be 12 minus 2. You can see this is 10, this is 18, this one has 18 electrons left, this one has 10 electrons, 18 electrons, this has 18 electrons also, and this has 10 electrons. So the answer will be what? Because this is 10, 10, 10. And for a neutral atom of neon, for a neutral atom, take note of this, the number of the atomic number is equal to the number of electrons. So if this is 10 and this is 10, this is 10, it therefore means that oxygen 2 minus and magnesium 2 plus are both valid answers, but we're giving it in an option. So in an exam scenario, you just go with option A, the one closest to the option list. So we'll go with option A. Now, the second question says, what is the percentage by mass of sulphur in aluminium tetraoxosulphate 6? And this is the formula for aluminium tetraoxosulphate 6. In the video 1 we did on questions 1 to 5 on particulate nature of matter, we solved the question on percentage by mass. But let's go again with another. Now, question 2. Now we said find the percentage by mass of aluminium, and this is a radical. Basically, radicals are groups of atoms that have a common charge and identity. Now, you see this is a radical. Now, aluminium tetraoxosulphate 6. This is basically saying this is Al2. Now, this 3 is basically for everything you see in this bracket. So it's basically me writing S times 3 will now be S3. 4 times 3 is 12. So oxygen will be O12. Now, they ask us to find the percentage by mass of sulfur. But first of all, let us calculate the relative molecular mass of this compound. Now, the relative molecular mass, aluminium has a relative atomic mass of 27. So basically, how many atoms of aluminium are here? 2. So say 2 times 27. Plus, how many atoms of sulfur do we have here? 3. So 3 times, what is the relative atomic mass? 32. Plus, how many atoms of oxygen do we have here? 12. Times how many? The relative atomic mass of oxygen, which is what? 16. Now, if you calculate all of this together, would have, so you get 344. Now, since this is relative molecular mass, it has no unit. Now, since we've gotten this is the relative molecular mass of this compound. Now, we're asked to find the percentage by mass of sulfur. So for sulfur, the simple thing you just do is carry whatever you did for sulfur. This is for aluminium, this is for sulfur, and this is for oxygen. So for sulfur, we have 3 times 32, so percentage by mass of sulfur will be equal to 3 times 32 divided by 344. Now, since we are trying to get the percentage, we multiply this by 100. Now, if you do this, you would have 27.9%. And therefore, our answer here will be what? 27.9%. So therefore, sulfur has the percentage of by mass of 27.9% in the entire mass of what? Of this aluminium tetraoxosulfate 6. Now, to question number 3, it says, how many molecules of white phosphorus P4 are contained in 248 grams of the substance? How many molecules of white phosphorus P4 are contained in 248 grams of the substance? Now, let us go. Question number 3. Now, for question number 3, basically there are 2 formulas we would need to know. The first one is the number of moles, N is equal to the mass in grams all over what? Your relative molecular mass or your molar mass. Good. Now, for this, we have that how many molecules are contained in 248 grams of the substance. How many molecules? Now, the second formula also is number of moles. This one I say number of moles also. So we can still use N is equal to the number of atoms or particles or molecules divided by 6.02 times 10 raised to the power of 23. So this is basically it. So these are the 2 formulas. First of all, let's see what we're given. We're given phosphorus P4, and we have that it is contained in 248 grams. Now, 248 grams is the mass, so mass is equal to 248 grams. Now, we are given atom P4, so therefore we can basically calculate the molar mass or the relative molecular mass. Now, so phosphorus has a relative atomic mass of 39, but we're given P4, so we can basically calculate the molar mass. Now, the molar mass will now be 39 times 4, which is 156. So P4 will be equal to 39 times 4, which is equal to 156 gram per mole. Now we can now calculate the number of moles. The number of moles for this, based on this formula, the first formula here, would now be 248 gram divided by 156 gram per mole. So based on this, 248 divided by 156 would have 1.59. So 1.59 moles. 1.59 moles. Now, since we are done with this, we know the number of moles. We are looking for the number of what they ask us to how many molecules. So to know the number of molecules, we just use number of molecules here. So N is equal to the number of molecules divided by 6.02 times 10 raised to the power of 23. So we cross multiply, but number of moles is what? 1.59. It is equal to the number of molecules divide 6.02 times 10 raised to the power of 23. When we cross multiply, the number of molecules becomes 1.59 multiplied by 6.02 times 10 to the power of 23. And our final answer would basically be 9.6 times 10 raised to the power of 23. And that's our answer. So we go here, our final answer will be what? 9.6 times 10 raised to the power of 23. Now, the next question says 4 elements W, X, Y, and Z have atomic numbers 2, 6, 16, and 20 respectively. Which of these elements is a metal? 4 elements W, X, Y, and Z have atomic numbers 2, 6, 16, and 20 respectively. Which of these elements is a metal? Now, first of all, what is W? We say W has an atomic number of 2. We also say X has an atomic number of 6. We say Y has an atomic number of 16 and Z 20. Now, for W, atomic number 2, the element with atomic number 2 is helium. The element with atomic number 6, carbon. The element with atomic number 16 is sulphur on the periodic table, and the element with atomic number 20 is calcium on the periodic table. Now, based on the periodic table, elements that are on the left-hand side of the periodic table are metals. And you would see that these elements are not on the left-hand side of the periodic table. Therefore, our answer is what? Calcium number 20. So, which of these elements is a metal? So, element Z is the metal. They say the electronic configuration of an atom is 2882. The atomic number of the elements is. Now, what is electronic configuration? Electronic configuration is basically the arrangement. This is question number 5. Electronic configuration is the arrangement of electrons around the nucleus. So electronic configuration is the arrangement of electrons around the nucleus. The electrons revolve around the nucleus. This is the nucleus. Now this is where the electrons revolve. These are what we call shells. And this, or you can call them orbitals. Call them shells or orbitals. Now they revolve around this circular part, or it is an imaginary circular part actually. So this is your nucleus, where your protons and neutrons stay and the electrons revolve around them. So the arrangement of electrons around the nucleus is what? Your electronic configuration. So basically your electronic configuration is, for a neutral atom, the number of electrons will be the same as the atomic number. Now, since this is a neutral atom, you just count the number of electrons here. So that's 2 plus 8, which is 10, plus 8, which is 18, plus 2, which is what? 20. And therefore, the answer here is what? 20. Now, the last question says, when an atom gains electron, it becomes. Recall from the question we did in question number 1. We said when we see O2 minus, it means oxygen has gained 2 electrons. So now, if oxygen has gained 2 electrons, this atom here will be regarded as this ion here, since it is now an ion, because ions are basically atoms or groups of atoms that possess charge, so that carry electric charge. So since it carries a charge, it is now an ion. So this oxygen ion here in this case would be said to be, they say, a cation ion. Now, what's a cation ion? A cation ion is basically a positive ion, just in the case of when we had Ca2+. So that's a cation ion. A cation ion are basically positive charged. So this is a cation ion. And therefore, when an atom gains electron, it does not become a cation ion. A complex ion, no, not in this case. They say negatively charged, and which is what? Correct, because oxygen when it gained electron was what? Negatively charged. Or you can say an ion. To remember this easily, just remember a negative ion. A negative ion. Anions are negative ions. So in this case, our answer is what? D. Thank you very much, and I'll see you in the next one.